the elementary concepts or the basic concepts of the signals and systems. In that, first we discuss about the elementary signals, which are the some signals like the first one is step signal, second one impulse, and basically we discuss the step signal and impulse signal multiple times. So we discuss about the step and impulse signals in both the cases of continuous time and the discrete time. So the step signal in continuous time, we write it as an u of t, okay, and in the discrete time you represent it as u of n. The same, the impulse signal also in continuous time, this is represented as del t and del n. So let us see first what is a step signal, a unit step signal or step signal. Let us see step signal. So in continuous time, this is defined like this. Sorry. U of t and the axis tip is t. So u of t will be like this from 0. So this is in the mathematical, which is expressed as u of t is 1 for t greater than or equal to 0. Okay, and for t less than 0, it's 0. It's defined as like this. The same if you observe in the discrete case, that is u of n, it is defined as like this. Impulses at the discrete positions 0, 1, 2, 3 like this. This is u of n. Okay, and this u of n is given as 1 for n greater than or equal to 0 and 0 for n less than 0. So you can write it as an n less than or equal to minus 1 also. Okay, like this you define the step signal in continuous time and the discrete time. Okay, let us see now the impulse signal. That is impulse signal del t and del n. So the impulse signal in continuous time is referred as like this, delta t. So here impulse only at this position. Okay, but there are a lot of definitions for this impulse signal. Okay, so in a general point of view and in the exam point of view, I am just saying like this. So actually this is not the proper representation of an impulse signal. Okay, so actual representation of the impulse signal is delta t dt integral minus infinity to infinity is 1. This indicates that the area covered by this is 1. But in our some textbooks, this delta t is given as like 1 for n equal to 0 and 0 and not equal to 0. So there is an ambiguity or some trouble to represent this step signal like this. So you can say a pulse, okay, a pulse of duration or width right, which is delta, and this position is minus delta by 2, and this position is delta by 2, and this is horizon, and this is t, and the height is 1 by delta. So the area covered under this, okay, the area covered under this is 1, area covered by pulse, by the above pulse is 1. Okay, so let me reduce the width, reduce the width of pulse and keep the area as 1. So for that you have to increase the height. So reduce the width and increase the height. So area is constant. Area is constant. Like this, you reduce the width very narrowly by maintaining integral delta t dt, by satisfying this condition. Okay, you reduce this width and keeping the height as 1, sorry, not exactly 1 by delta, you reduce the width and you make the area as 1. So like this you diminish the width, and this leads to very narrow width, and like this representation of a line on the vertical axis at the point 0, okay, like this. But in the discrete time del n, this is at the instant of 0, that n, the value is 1. Okay, so here delta n is 1 for n equal to 0 and for 0 to 0.